Only one we haven't talked about. We have spent so much time on the rigid motions, we have not given any love to the dilations until today. All right, just prepping you mentally. We got a lot of things to cover here with the dilations. I'm still not going to give dilations any love yet. The first thing I want to talk about, invariant points. Invariant, pretty easy, right? Hey, points that do not change after a transformation. Or I'm going to say points that do not move after a transformation. So I graph a figure. I ask you to reflect, rotate, translate. Point doesn't move. That's an invariant point. It stayed right where it is, invariant point. And I don't want you guys to waste our time here graphing. So I have this quadrilateral up here. Okay, I have this quadrilateral. Somebody name me a transformation that will result in point B being invariant, meaning it won't move. So tell me something I could do. Get specific, please, too. Something I could do, one of the transformations we've talked about, where point B, it's going to stay right where it is. Caleb! Everyone agree if I reflect this figure over the y-axis, is B going anywhere? Nope. So I could reflect over the y-axis, sure. Nice job. Nice job. I'm going to challenge you. Because I know you hate to hear this, but they tell me I have above average in here, so. And don't be the kid, translate 0, 0. Rotate 360. I don't want to hear that. I want something else. What do you got, Mason? Okay, where B is in the center. Let's get somewhere else, somewhere there. All right, I don't want B to be the center. Here's what I want, though. I'm going to give you a little hint. I want another reflection. Got it, Christian? A horizontal line of y equals -3. Yep, that won't go anywhere. Good, good, good. All right, give me something where point D would be invariant now. Point D, meaning D would not move. I don't care about B anymore. I'm going to point D. I think it's time to open up the numbers here. Whew, let's open it up. 27, let's open it up. What could I do with point D? It goes nowhere. Reflected over the x-axis, absolutely. Or reflected over, now that you know, it should be a little easier now. What line could I reflect it over? Other than the x-axis. Hi, Emma. X equals 3. Perfect. Yep. All right, so everyone good? Invariant. Points don't move after a transformation. They stay exactly where they are. Issues. All right, now let's give it a little love now. Little dilation time. Here we go. Go ahead and get a little triangle ABC up there. All right, here we go. We're going to dilate it by 2. So first thing, you guys, is this thing going to get bigger or smaller? Bigger. Okay, yeah, it's going to get bigger because that number 2 is bigger than 1, so we know it's going to get bigger. But I don't want you to start thinking like that anymore. Because what's going to, hey, ready? Hey, what's going to happen to point A? Here's point A now. You're telling me this is going to happen to point A now? It's going to get physically bigger? No, that's not what happens. Yes, the figure ABC will get bigger, but what actually happens to the points? That's what I want to drill home today, was what happens to the actual points when you dilate. Everyone agree right now, A has some distance from the origin. We're all good there. I don't care what it is, but it's got some distance from the origin. When you tell me we're going to dilate by 2, that distance is going to double itself. So C, right now, everyone see point C? How far is it away from the origin? You can count that sucker. Go ahead. How far away is it? 4 units. So it's not going to be 4 units anymore. It's going to be 8 units. So do you see what every point is doing now? It is doubling its distance away from the origin, and then that is what makes the figure bigger. Okay, because we're getting further away. So here we go. A prime. How do I figure out? Anybody know how to figure out the new point? What do I do in a dilation? Beth? Multiply, multiply, multiply. Whatever the scale factor is, in this case 2, that's what I multiply both my x and my y by. So A prime will become 2, comma, 4. B prime, 8, 4. And then finally C prime, 0, 8. Ooh, got enough spots. So you will now see every point is doubling its distance away from the origin. So go ahead and graph A prime, B prime, C prime. A prime, look, further away now. B prime, further away from the origin. And as we already said, 1, 2, 3, 4, 5, 6, 7, 8. C prime. That is why the figure gets bigger, because all those points are getting further away. Next, now do the double prime, the image of which triangle? The original ABC of 1/2. Now, you tell me now, what's going to happen to A, B, and C? They're going to get closer to the origin. All right, that's why this triangle is going to be smaller, because A, B, and C are going to get closer to the origin because this is 1/2. All right, same thing, multiply all the coordinates by 1/2. A double prime, B double prime, and C double prime. All right, little help. Can I get a little help from 25? Can I get a little help? A double prime. 1/2, 1. And you can estimate that, not looking for preciseness. B double prime. And C double prime. All right, everyone, here you go. Watch all the points now get closer to the origin. That's not A double prime, that's C double prime. Tiny sucker now. So do we see now? I get it, the figure's going to get bigger or smaller, but everyone understand why now? Because the points are either going to get closer or further away from the origin. That's the big concept here. All right. Can you dilate a line? Woohoo! Here we go. Around a point that's not the origin. I just raised the level like 20 times here on this one. Okay, I got line n, 3x plus 4y equals 20. Find the equation of P, where after I dilate this line by 1/3, stop right now reading, 1/3. Are all the points on this line going to get closer or further away from 4, 2, the point I'm dilating around? Closer, because it's 1/3 in between 0 and 1. So all the points on this line are going to get closer to 4, 2. How much closer, and how can we find the actual points? Let's do this. Probably a good idea first would be to do what with 3x plus 4y equals 20? Put in y equals form so I can graph this sucker. Darn right. All right, I want to see what this line looks like. That's why you guys have a straight edge today. And of course, we're going to do a construction. 12, can you help me out? What's the first step to get it in y equals form? All right, I like it. So I'm going to be left with 4y equals negative 3x plus 20. All right, next. 19, get that in y equals form. One more step. Oh, easy, champ. How are we doing it? Divide by 4. All right, go ahead. Now you can show off y equals. Just 3 over 4? So negative 3/4 x plus 5. What's the y-intercept? Everyone go to 5 on the y-axis. 1, 2, 3, 4, 5. Can you guys get me more points to graph? Without going into the calculator. What's the slope of this line? Down 3, right 4, or up 3, left 4. You make the call. Plot a bunch of points, grab that darn straight edge, and let's see this line. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3. Okay, we all got the line there. Go ahead, finish it up. I want you to get this. I want you to get this one. We said 1/3. All points are getting closer. Closer to what point? I'm not dilating around the origin here. They're all going to get closer to which point? Hey guys, find out where 4, 2 is right now in your graph. Where'd it land? Oh! There's 4, 2. Let's think about this. Come on, dig deep. This point, this random point on the line is going to get closer to 4, 2. Where is it? It's still on the line, isn't it? This point way up here is going to get closer to 4, 2. Where is it going to land? Somewhere where? On the line. What am I trying to show you here? No matter what point you pick, you get closer to 4, 2, which is already on the line. Where's it going to land? On the line. So what's the equation of my image then? You're right. Same line. All right. Because this point, the center was on the line, all points are going to get closer. Are we ever going to get a point off the line? No. So my equation here for line P is going to be, you can take the original one, the one we transformed, it's up to you. 3x plus 4y equals 20. Does everyone say, we're not changing the line? We're not changing it. Every point is just getting closer to this one, which is already on the line. Now, if it was off the line, then we'd have a couple things to deal with. But it's not. Okay? It's not. We okay there? Because that's for some reason, they always try to trick you with that question every year on the regions. If it's on the line and you're dilating it, a point on the line, it's the same thing. Questions? All right, what if it's not on the line, right? We got to cover that topic. What if this darn thing's not on the line? You got it. Here we go. Next one. So you got triangle ABC. We're going to dilate around point D. Scale factor of 2. Point's going to get further or closer to point D? Further. We're going to double the distance, right? We're going to double the distance. 24. Who's got 24? Give me a point to start with, Nam. Point B. You got it. So point B is going to be twice as far away as it is now from point D. How can I do that? I don't want distance formula. I don't want any of that garbage. I want something I can do right on the graph that will double its distance right away. What? Here we go. Show us, Remy. Show us. Ready? Where do you want me to go from point D? D to B. Give me directions. Up, 1, 2, 3, over. 1. Double it. Ready? Up. 1, 2, 3, over. 1. There's B prime. There's B prime. I just doubled the distance. Everyone see that? By 2. If it was by 3, I go one more time. If it was 1/2, I'd cut that in half. All right, let's go. Who's going to do the next one here for me? 26. You got it, stud. Point A. You tell me where to go from A to D. Or D to A, excuse me. 1 down and 1, 2, 3. And then I'm going to go 1 down, 1, 2, 3. Good. It should not be on the other side of D. All right, it should not be on the other side of D. All right, and then I need a little help. Number 3 with point C. 1, 2, 3, over 1, 2, 3. Ready? Down 1, 2, 3. How many am I going over? 1, 2, 3. C prime. And yep, your triangle should get bigger because it's bigger than 1, that scale factor. We okay there? So we can do it when it's not the origin. If it was the origin, you can just multiply, remember, like we did in that first example. If it's the origin, you can just multiply. Questions from you guys? All right, yep. Do a little proof type on the next one. ABC to A prime, B prime, C prime. What did I do? What did I do? Name the transformation. Describe it for me. What did I just do? Translate, rotate, reflect, dilate now. What did I do here? 14, what did we do? Dilation, okay, but as you guys know, one word won't cut it. I need more specifics. Dilation with a scale factor. You guys can find that out. Of, I'm hoping that you're going to give me a number bigger than 1 because this is an enlargement. A dilation with a scale factor of, pick 2 corresponding sides. You can find the distance of. Three, here we go. How long was BC? 6. Did you count B prime, C prime? I think you were 1 more. You counted an extra one. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15? Okay, now knowing that, what's my scale factor? 6 over 15, 15 over 6. Why? Why'd you change your mind? Has to be larger than 1 because I have an enlargement. So you guys can leave it. Any studs reduce that? Or what is that reduced? 5 halves? Or 2.5, whatever the, okay, that's fine. Why are they similar? Obviously, they're not congruent. Why are they similar? Oh, what do we, well, first of all, what is this? Dilations, right? Are they rigid motions? No, so don't put that in. That's a little silly. Dilations do not change. Angle measure, good. Dilations do not change. Angle measure. Henceforth, thus, in conclusion, I'm done with that one. What are we using today? Thus, pretty. Triangle A prime, B prime, C prime is similar to triangle ABC. Need one more piece there. Well, anybody remember? Good review. Main reason we prove triangles similar. What is it? Billy, nice job. One more time. Angle, angle. I just mentioned the angle measures don't change. Thus, they're similar by angle, angle. Bless you. Questions? All right, in your group right now, a minute. See if you guys can figure out 5. I don't want to say anything here. Go ahead, in your group, talk it through. So you got AB, but I want the length of A prime, B prime after I dilate 1/2. Couple different ways you could do this. Talk it out if you need to. Talk it out. All right, you may be finishing up. I just want to hear how you're going about it because there's 2 different ways we could go about this. 24, how you guys going about it? So you did the distance first and then did what? Cut it in half, right? Okay. Anybody apply the 1/2 to the coordinates first, then use distance formula? Perfect. Okay, either way, you find the distance, cut it in half, or multiply the coordinates by 1/2, then find the distance. Either way, it'll end up 24 again. Why don't we finish this, Nam? What'd you guys get for your distance? 2.5, yep. So the distance, A prime, B prime, no matter how you did it, 2.5. Anybody having issues either way getting 2.5? All right, I'll give you another minute to go ahead. 6, 7, and 8. We are dilating around the center, the origin, so you can multiply by the scale factor. So give me all the new coordinates now. And then we have to learn how to use our compass to dilate. rattle. 4, here we go. Here we go, number 6. I need P, Q, and R. Negative half, 1/4, yep. Q prime. Yep. 5/4, negative 1/4, or the decimal if you left it as a decimal. R prime, finisher, the finisher. 7/4 to 1.75. Good, any issues? Okay, let's keep this train rolling, then we can grab the old compass. And I had 4 on that one. I don't know why you answered, but thanks. No, number 6. We are on number 6. One job. Oh, this one right here. Yep. Okay, it's 7. Okay, you're up. Yep, Q prime. And I'm just going to call it the next one now. 23, next one, P prime. All right, decent start. Okay, not bad. All right. Questions? Grab that compass. Let's rock and roll. Not going to teach you anything new. You've done this already. We're going to dilate this around O, scale factor of 1/2. Somebody tell me from all our darn discussion today, what's going to happen to A, R, and T? Are they going to get further away or closer to O? Closer, closer, closer by 1/2. So that distance is going to be cut in half, literally. So ready? I'll ask somebody because if I have a class decision, I'll get chaos. 6. Now here we go. Which one do you want to dilate first? R? Okay. So everyone agrees R is going to get closer to O. All right. How much closer? Half the way. So ready, everyone? You have a distance right now from R to O. Using a construction we have already done in quite detail this year, how can you find R prime so that it's halfway between? Or it looks like we're going to be using that cell phone case pretty quickly in here. One more time, that's all it's going to take back there. What do you got for me? Perpendicular bisector. So everyone's got the segment from R to R prime. We're going to do the perpendicular bisector. And where it intersects that segment, there's R prime. So take your compass, put it on one of the endpoints. And hey, guys, I'll save you an extra line. I don't need to see the full line drawn in. Line up your straight edge right now. All I want is the point on R, RO. That's going to be R prime. You guys do not have to do the full line. That's just an extra line that's not needed. Line up your straight edge. Mark the point where R prime would be. Mark that point where R prime would be. So there's R prime. Go ahead and do the same thing for A and T now. T might be a little tough with some of your compasses. I know it's not that long of a distance. So we have a smaller everyone go smaller triangle. I'm not done with this talk either. I got one more for you. You're gonna just describe to me how to do it. Okay, here's my question. Same triangle, same point we're gonna dilate around. I changed that 1/2 to a 2. What's gonna happen now? What's gonna happen? Are the points gonna get further away or closer? Further away now. How would I use my compass now? Ready? I take TO. How do I double that distance now? How do I double this distance? Where do I go now? Thomas, go ahead. So measure that, put it on T, and I've doubled it. The one thing you want to make sure of, I've seen this way too many times, don't go on the other side. Okay, you're not getting further away. You're just keeping the distance the same. You got to go further away. Okay, so if that was 2 instead of 1/2. All right, you got one question in your packet and the rest are out of the book. Graph means graph, remember. Make sure before you leave, all the compasses and straight edge get put back.